My name is Brian Woodbury, and I get to speak with you for the next few minutes on our Strands and Cables product line. But first, before we get started into that, I want to talk about a little bit of terminology just to make sure that we're all on the same page. So when we talk strands and cables, you might be wondering, well, what's a strand? Well, a strand is formed by wrapping individual filars or filaments, or what we would call a wire, together. So strands are typically in a 1x configuration. So as an example, a 1x7, which would be 6 wires wrapped around a core wire, or a 1x19 are popular stranding options. When we take several strands and wrap them together, this produces a cable. Cables could be a 7x7, which is a cable of 7 1x7 strands, or maybe it's a 7x19, which would be 7 1x19 strands. Regardless, Fort Metals can produce the most complex cable that we can do is a 37x37 construction, and in that 37x37 construction, there would be 1,369 individual filars or wires inside that cable OD. The outside diameter can be as small as a 002 or as large as 0.1875 inches. We've also successfully stranded as small as 0005. And really the trick of stranding and cabling is finding the correct balance of flexibility, brake load, and torque for your particular application. When we talk about common materials, this list basically matches what we say here at Fort Metals, that if we can draw it, we can strand it. And as you can see, there's a list of stainless steels, cobalt chrome alloys, DFTs, and other high-performance alloys that Matt just alluded to. All of those alloys are able to be stranded or cabled in our facility. Now with this slide, one thing I wanted to highlight was, as you can see on the left, the graphic there that demonstrates as wire count increases, flexibility also increases. However, brake strength has an inverse relationship. Brake strength will reduce as the filar count increases when you compare similar items of the same OD. The chart on the right shows a more detailed view of very common strand and cable constructions. It allows you to compare the relative strengths on the left and the number of filars on the right of the chart. So that way you get an idea of, as you can compare the different constructions to each other. This chart is actually out of a brochure that exists on our website. So if you go to our technical literature and search for the Strands and Cables Configure brochure, you can get this chart as well as a lot of other detail related to strands and cables. One additional technique we can provide to the customer to get that perfect combination of brake load to flexibility is a compacted strand, or sometimes you might hear it referred to as a swage. This technique takes the strand through a secondary process to rotary swage the exterior. This compacts the filars against each other. This removes some of that internal interstitial space, stiffening the construction. It also creates a smoother exterior throughout the length of the spool. Fort Metals may recommend this process to increase brake load or decrease flexibility in the same OD. It can be used to increase the sliding factor of the item as well. And then, as noted there on the right, the percentage of compaction is really dependent on the construction. But if you think this could be helpful in your application, get a hold of us and our Strands and Cables engineers, and let's have a conversation. One last thing I wanted to know as far as strands and cables go is we do have a configuration tool on our FWM Metals website. This is a great way for engineers and designers to get started by simply selecting 3 parameters by providing the material you're looking for, the min brake load, and the max OD. The calculation will provide constructions that meet those parameters, as well as provide a max brake load at that selected OD. If you aren't finding what you're needing, or you need a solution that maybe is on the fringe of what the calculator is saying is possible, please connect with us and we can discuss other possibilities. Now that we've discussed a bit of the technical details behind strands and cables, I wanted to highlight where you might find Fort Metals strands and cables used. They are often used in orthopedic applications like securing ligaments or bones. We see them in minimally invasive instruments or used as guide wires, stylets, or endoscopic devices. They are also heavily used as is heart pacing or nerve stimulation leads. This list is just a partial list, but gives you a sampling of the many applications that were used in.